Ladies and gentlemen, good morning, good afternoon, wherever you are in the world. Welcome to our year-end webinar on securing DLT-based CBDC infrastructure. As we are coming to the end of 2023, a year that has been marked by advancements and discussions surrounding CBDCs and bringing us to the forefront of the financial revolution, it is imperative to recognize the crucial role that security measures play in establishing the credibility and the resilience of CBDCs against an evolving backdrop of technological challenges. So, without any further ado, it's my pleasure to introduce to you today Taha Sajid, our speaker for today. Taha is a principal security architect and 5G security lead at Comcast, oversees security design for the end-to-end 5G network. He is also a cybersecurity expert, advising central banks and other financial organizations. Taha is an author and an e-learning instructor as well. His 5-star rated book, Ultimate Blockchain Securing Handbook, and courses that he's offering cover cybersecurity for 5G, blockchain, DeFi, and fintech, benefiting thousands of professionals. Taha has received several global honors, including Microsoft MVP, for his contributions to developing technologies and media features for his publications on critical IT concerns. Taha, the screen is yours. Thank you.
Hi, Saula. Hello, everyone. Thank you for the nice introduction. And it's been an honor for me to come here as a presenter in this seminar. And I'm really looking forward for an exciting session. Let me share my screen. Can you all see my screen?
Yes.
Okay. Yeah, so I'll start off with explaining the agenda of the presentation. The first topic for me is will walk through is why it is important to secure the DLT-based CBD infrastructure. What are the considerations that you have, and why do you care? Basically, why it is important, and what are some of the security concerns we have for the CBDC DLT-based infrastructure. In the second topic, I will go through a security framework for CBDC, in which I will explain you some of the tools and activities that we can take across different security domains, which will help you to see that what are the different areas which you want to protect for mitigating risk. The third section is the future of security. So we see that cybersecurity has been evolving as we get advanced in terms of our technology stack. We see that hackers are also getting innovative in how they are hacking the infrastructure. So I'll present a view that where the cybersecurity industry is going towards developing and improving its own posture with zero trust security enforcement. This is something which I would like to explain. Then in the last section, I will go through the recommendations, that what are the takeaways from this presentation that you can take, which will help you in designing a good architecture for your solution. And I'll encourage you all that if you are in any of the slides, if you do have any questions, please feel free to put it on the chat, and it will also help me to understand that whether you are getting some of the topics or not, because this is very important. Okay. Uh, so Saula have already introduced me. Just a brief view to some of the things that I have done over the past years. And if you want to connect me over LinkedIn, I have put it here a QR code, so I'm easily accessible. If you have any questions after the presentation or anything you want to connect with me for any like guidance or any other feedback, please do let me know. Okay. Now starting this, so why do we care about securing DLT based infrastructure? We have seen now to to actually to actually set the stage here. You have seen that a lot of governments are doing POCs, and some of them are in the development stage, some of them are still experimenting. There is a lot of interest that has been there for a DLT based CBDC infrastructure. And as we become more focused on, and as we are exploring some benefits from the DLT based CBDC implementation, we have seen that like some of the like learnings that the governments are taking. So as but the main idea of having this CBDC design is to bring like for me is to bring financial inclusion to, but on the same side, it is an important aspect that we are talking about an economy infrastructure which it can directly influence a lot of sectors of the economy. So in terms of the research and pilots around the world, you can see that there's a lot of for different parts of the world are doing different projects. Some of them, like in some parts of the world, we see that there is I mean, CBDC is live, and I mean the retail CBDC, especially which is for the public, it is live. Whereas in other parts of the world, we see that the pilot is still going on, and some parts pilot is completed. Then in the other side, especially the Middle Eastern and Asian countries, there is like some retail research are going on for both the sections, which is which is the wholesale, and the retail CBDC. So, but the main takeaway, which you can get from this is the interest is there. Yet we are not. Still, we have a lot of work to do, but it will get there. Well, like when this is what we know of from all this work that has been going on. So this is the main reason that if you are having this CBDC, you know, the movements going on, and there is a lot of research and pilots happening around the world, so you have to make sure that whatever they are doing, and we are having, it's secure. There is no like vulnerability or loop areas that can come in this whole development cycle. So this is something which I which is my agenda for the presentation is as well, is to give awareness and to make sure that where are the areas, like what we can protect. Okay, now if you think from the DLT based CBDC infrastructure in terms of that, what are the areas that needs more attention, and why we would like to emphasize on those areas. Basically, one is like maintaining the robust payment system. So if we are having secure and hack proof, there's nothing like a hack proof thing around the world, but at least we can try our best to make it less vulnerable. It will help us to have a robust payment system, and then it will create trust in the payment instruments. So even if it's a wholesale CBDC, which is based which is designed for the commercial use case for banks to banks communication, or if it's retail CBDC, which is meant for the public, you are if you are protecting your assets and your communication, you are protecting your end assets and public in general, and it will create a trust between the public, amongst everyone, if the payment instrument is secure. And the next is it's an end user asset and confidential personal information security. So if you are protecting your CBDC infrastructure, it will help protecting the end user assets, which is like if it's a retail CBDC, it's a mobile wallet, in which how the people are interacting with the central bank. If it's a commercial bank, if it's a wholesale CBDC, then it will be the commercial bank's payment rails, the endpoints what they are using to interact with that software. And what it will do, it will help the system to protect the personal identifiable information, because the one thing which becomes vulnerable when the system comes under attack is the personal and the sensitive information which is part of the system, and which the hackers can able to exploit. So this is, with this in mind, it will help to safeguard the user assets as well as the PA information. And lastly, last but not the least, it will help to keep the central bank reputation safe. So imagine if there is a hack or if there is something which is happened wrong in the design, and if there are some weakness which is being exploited. So think about a country which is having the CBDC implementation. So what will happen if there is something like a leak or a cyber hack that has happened? The trust will be impacted. So this is something which is really important, and this is why we want to have a framework or to have some sort of a solution which can safeguard all these points. Okay. So before I go any further, are there any questions up till now?
No, we don't seem to have any questions yet. At least I don't see any on the chat and the Q&A that we have here. So we can leave all the questions at the end if there are any.
Okay. Got it. Okay. The second topic is the security framework for CBDC, because now if you think cybersecurity, it's such a big domain. It has a lot of angles to it. You can protect the code, you can protect the cloud infrastructure. So what should we target first, and how do we make sure that we are covering all our bases? Because if you think from the risk perspective, if I ask you a question that, hey, can we build a system which is 100% secure? I mean, the answer is no, because there's nothing what you can do. What you can do is to do your due diligence, but you still have to have some sort of an angle in which you can see that, hey, what are the different areas, like what are the main areas what I need to focus. So this is where I would explain you that what are the framework that you can follow to build a secure CBDC. Now, this is like the main, I would say, these are the 6 main areas which are there, which you need to consider when you are building your CBDC design. Starting the first area, which I'll explain a bit more in the presentation, is identifying the risk, which I have actually highlighted, here in this circle. Is if you are able to identify the risk, then you can maybe in a position to better control the risk. Because if you, let's say, if some risk like are not taken care of or not identified, then you'll not have the visibility to what to protect. The second area is the risk prioritization. So when you identify those risks, you have to actually classify, quantify and qualify that, hey, whether it's a higher risk for me, what is the impact for this risk, what is the probability of occurrence of that risk. So I will go through each of these domains in a deep in more details, but here just to give you an overview. Then the third phase of it is the solution design. So when you are if it's a token-based infrastructure, or within DLT, you get certain options as well, that you can have token-based or you can have your coin-based infrastructure. So when you are doing a solution design, like taking the requirements and making and evaluating which protocol to use in layer 1, layer 2, how that application layer would work. So this is the phase where you do your solution designing of your whole entire solution. So if you are identifying your risk earlier, it will help you to shape your solution or to design your solution better. Then the fourth stage is the solution validation. In this stage, you will make sure that the requirements and the design that you have built is being fulfilling the requirements, and this is where you will interact with different stakeholders in trying to, you test your solution. The fifth phase is the operational security phase, where you will make sure that like all the patches, all the operational aspect of the solution is working. The key performance indicators for your solution, which is, for example, if it's a payment, like payments per second KPIs, or if it's took a risk per domain, whatever like operational security you have kept initially or took our meeting. The last criteria is the policy orchestration. So when you build your solution, when you do the designing, you do the validation, you making sure that all the security aspects are there, you need to have a policy sort of a mechanism in which you define that if, for example, if something goes wrong, how would you take an action? What are the different what are the different enforcement points you have for the policy? If I need to strengthen my risk profile, if I for some of the risk, if I need to deprioritize them, what will happen? So how I would orchestrate my solution. So this is something which you need to have in mind, that you need to have a policy orchestration like domain in your solution. Now, for identifying risk, one practice which I would like recommend you is the use of the threat vector analysis, which is also called threat modeling for CBDC. In the threat modeling exercise, there is a framework which we normally follow, which we call as the STRIDE framework. STRIDE, like S for spoofing, in which if for example, if somebody is impersonating me, like meaning that if it's claiming that, hey, I'm that claiming to be someone else, so this is where you have to think about that it's a property violated for authentication. So this is what spoofing is. So tampering is you are tampering with the information. The information which is being transferred is not the correct information. Repudiation is something which is, for example, if there is a hack that has happened in your system, and if you're not able to track that hack, this is where the repudiation comes, that the attacker can get away with whatever he's doing without being getting caught. Information disclosure is a threat where you are, like for example, if it's CBDC use case, the endpoint, the mobile phone gets under attack, and the attacker has got the information of the user, okay, and it is disclosing that information on the dark web. This is where the information disclosure comes. Denial of service is if it's a system which has been working, and if there is a ping attack which is having sending a lot of packets to the system, and the system cannot process that information, and it becomes non-available. So this is where the denial of service comes. Then the last is the escalation of privileges, that if I'm using, for example, a read-only, I have the privilege of read-only user. And if I'm able to access only certain information, however, I can maybe escalate my privileges to get a root account or to get an admin account to get more information on the system. This is where this threat comes. So if you notice all these threats, what you can do, you can in the architecture what you are building, you can map all these threats, which I have explained you in the left side, on your solution, and assess your solution from that. Who would be the actors who are able to carry out these attacks? If it's an internal actors which are part of your organization, which is, for example, in the CBDC case, it can be commercial banks, it can be central bank employees, the system architects of your solution. This is something which can be carried out internally or externally, meaning that if it's a state-owned actor or if a state-owned hacker, would they be able to come in? So you have to evaluate your threats from the internal and external perspective, and then see that what makes sense for you. So for example, if if it's an API which is being exposed for public, so this threat is mainly for the external threat, so there is for external communication which can be impacted, versus if you are having a private network which is only defined or only restricted to your central bank, it is not being exposed publicly, but then it is a matter of somebody who is internally, who has gained an access of internal systems, he is able to penetrate across the network. So you have to make sure that what makes sense for your network. But the common theme here is all these threats actually comes under three main categories. One is the confidentiality impact, which is for any of these threats, it will either impact the confidentiality, which means that your privacy of the solution, meaning that if it's a confidentiality threat, meaning that if somebody is spoofing you, or he has taken access of the system, he can take your personal information, so he can extract all the information what is there in the system. So the impact can be either on the confidentiality or data integrity, meaning that the data integrity, the data of the system may be corrupted. The hacker has got access to the system, has taken access to the system, and he's now changing something on the operating system. He's making some corruption on the files, or the data is not there. So it can be either on the integrity. Then the third part of it is the data availability, meaning that the hacker has taken control of one of the systems, and that system is not able to operate anymore. Okay, so the attack can happen on the availability. So any of the threats what you see or in your network can have an impact on these three criteria. Now, how to make sure the next stage for you after assessing the impact is to define that what is high severity for you versus what is medium or low severity for you. How would you do that? I would explain you that here, for example, this is just an example of a disclosure of secret private keys or data leakage related to the cryptographic vulnerabilities. So now, when you have defined your threats, which is, for example, in this case, quantum computing may render existing cryptographic primitive insecure. So if there is a cryptographic algorithm which is used, and there is with quantum cryptography or with quantum computing, you may be able to break that algorithm which is being used for public key encryption. Okay, in this case, what is there? The hacker is trying to exploit your confidentiality of the system and also integrity of the system, meaning that if he can break the algorithm, the hacker can take the access or can read the information what is been traveling across that path, and also it can change the data, so it has an impact on confidentiality and integrity. If it's a DLT based solution, meaning that if it's related to the protocol of the system, if it's yes or no, or what, if it's in the application stack, so you have to make sure that it is related to the DLT or not. Then what is the likelihood of occurrence? If it's an internal network which is not being exposed, it is a relatively medium probability of the attack to happen. Whereas if something is exposed to public, meaning that particular system, for it to function, it has to rely on some external information. So the external information has been coming for that system. So in that case, the likelihood would be high, of the attack to carry it out. So in the cybersecurity term, it is like one of the main or the favorite clauses. What I is if the hackers, if the hackers can read the information, he'll be making sure that he can also exploit or hack or try to hack that piece of information as well. So this is where you have to be very careful that what architecture or what interfaces of your solution are exposed to the public world. Okay, so here you will have an idea to how to quantify and classify your threats. So what you have did is just to backtrack all this and to make sure that you digest the information. We started with identifying risk. Okay, then in the identifying risk stage, you are doing the threat modeling on your architecture. You are identifying different threats internally and externally. And then in the second phase, you are actually quantifying that risk in terms of like what is the impact, whether it's a likelihood of that impact to occur, if it's and what it is related. It is a DLT based or not DLT based. So these are the things what you can do. Now, in terms of the framework, I have explained you that I have explained you earlier that that cybersecurity is such a big domain, and you end up identifying 1,000 risks, and when you want to remediate those risks, you think about, hey, this to remediate this 1,000 risk, I have to spend maybe $1 million, and the solution is only worth of like 100K. So you have to make sure that you are covering all your bases and you are doing only what is necessary. This is an important aspect of building any framework. So the first part, which I have already explained you with, so it is identifying risk. In this domain, we carry on the threat modeling workshop, which has just explained you like one of the things. Well, it has other activities as well. You do penetration testing where you build a red team, a team of hackers internally, and you ask them to exploit your system and to make sure that it is free of bugs. Okay, you carry out the supply chain analysis, that where are you getting your software, whether that software has integrity protection or not. You carry out the privacy impact assessment questionnaire, that hey, if there's any privacy information that is being part of my system, how I'm safeguarding that information, how that information is being flowing across different systems. Okay, this is where you do this privacy impact assessment thing. Third-party vendor security assessment, you also carry out making sure that whatever third parties you are using, for example, if it's exchange, a bank, any like software, like a payment gateway, what you're using. So any third parties which are interacting with you, if they are part of your architecture, then they can impose some risk on your solution. So the first part is identifying risk. Okay, now what should we do after identifying risk? We should prioritize that risk, because we cannot protect 10,000 risks. We should make sure that all the risks of what we have identified is making sense, which is you have to like make sure that it is either impacting confidentiality, integrity, availability, and what is the severity level of that threat. Then you have to also check, one of the main things is you have to also check what are the direct and compensating controls on confidentiality, meaning that if it's already you are having, you are using TLS for your API communication, which is in that TLS communication, you are having your encryption channel, which is the information is not being transmitted in a readable format. So this is already you have implemented. Now you should not be putting access control or some extra more solution, which will make things complex for you. So you have to assess before you put some like security controls. You have to check that what is already in there in the system. Okay, then you have to check the dependency analysis, if I have some dependency or not, if I'm using that system. So the main part is, although we are actually prioritizing our impact, but we should not make things, we should not make things complicated and costly for us to do it. Okay. The third phase is the solution design and validation, where you will identify the security solutions which provides like maximum attack coverage across the stack. What are the performance impact on the system if I'm using those controls, and what are the security design for application transport and infra layer. So if you think from the stack perspective, you build an application layer first, then there is a middle tier which connects your application to your backend, and then you have your infrastructure. Either you use a cloud-based infrastructure or you use an on-prem, like you build your own data center clouds. Okay, so whatever you do, you make sure that all the three stacks, all the three layers of the stack is covered. The fourth stage is the solution validation, where you do the testing, stress regression testing. So here, like some companies also include bug bounty testing, hackathons they do inside the organization, that hey, you have to make sure that whatever you are building is free of any bugs. The operational security comes where you define what are your incident fault, change management procedures. How would you apply hot and cold patches if something goes wrong? You have to keep on assessing the data lifecycle management, and that if the data is being scaling, so how would you make sure that it is being resilient as well? So here you will define backup policies, some disaster recovery settings. The PKI is a public key infrastructure where you define that what cryptographic keys that you will be using. Policy orchestration is that if something goes wrong, and if you want to block a port or shut down a traffic or isolate that environment, how would you do this? So you have to define some sort of like a governance model for your solution, that how would you protect the solution based on zero trust. So this is something which I'll cover in the next slides, so just bear with me like for now. Okay, so moving on, the future of security. Before I actually take you to the zero trust security, I just want to like give you a context that, hey, what we have covered here in this last slide is something which is which needs resources, which needs cost, which needs proper planning, so all these things, if you are skipping some of the steps or not prioritizing some of the steps, you may end up spending a lot of money, and still you'll say that, hey, I spend $1 million for my security, and still I'm been having a lot of risk in my solution. So what should I do? You end up spending more, or you outsource your solution to a third party auditor, which makes things more complicated for you. So this is something which is there, that it is a hard thing, it is a complex thing, and it is mostly been overlooked. So when I say overlooked, I mean that when you want to like design a solution or build an application, you just want to just do it, and then when you without focusing on security, and when you end up having an attack, then you think, oh, I need to identify the risk early, so I need to think about cybersecurity early in my solution. So this is some of the things which is actually comes by default within cybersecurity, that it is always an afterthought. So this is something which the zero trust helps us to solve, okay, which is to build a framework that it should have a control plane, which is a policy engine for your solution, where you define that what I should do if there is a like cryptographic algorithm is weak, or if there's a threat for me for internal actors, or my external interfaces are not secure, so you define in the control plane, you define the policies of your solution, and in the data plane, which is the bottom tier, you say that, hey, if there's a threat to me from internal actors, then I should have a firewall in place in my data center, for example. Okay, so here you will define what are the security controls you want to use. Okay, and in the left and in the right hand sections, you use some sort of supporting tools which will enhance your control and user plane communication, or the data plane communication, which is you use threat intelligence, you use activity logs to monitor what has been going on, you check the compliances part, you check the public key infrastructure. So all what security solutions you can use, they are the supporting actors for you. Okay, but the main underlying architecture you are distributing into control plane and the data plane, where you define and act on the policies. Now, what is different with any other solution than zero trust? Zero trust will give you more visibility about your system. Okay, it is making sure that you are taking the actions equally for the internal and external actors, making, like, for example, if I have a rule for like person A, if person A is a manager, he can access all the systems, versus if there's an employee, he can access certain systems. So there is a way to define the security for different set of classified information. But here in zero trust, what we are saying, that we should be doing the same thing for everyone. Okay, making sure that there is no like a tolerance that we are expecting out of this. So this is what zero trust is. Now, to what it can bring to the table, it can improve your security posture, meaning that you will be having more visibility on your system, making your device, whatever, like your device communication, your user communication would be only allowed if it passes through the trust metrics, It can gives you more control, meaning that if you are defining some policies across your network, any communication which has been happening like from the users or from the systems communication, it is more control. You have authentication in each step of that stack. It can simplify compliance for you. You don't have to do separate things for separate solutions. You should have like a one governance policy where you can define policies and that would apply across all the stack. It can help you in cost control. You know that, hey, I have these prioritized risk only, and this is the stack what I have to control, and this is the only thing which I need to protect. You should have limited control. You should have like limited solutions on your whole stack. This way you can cut the cost for you. Okay. My final recommendations is whenever you are defining a DLT based architecture for your CBDC, making sure that you are identifying the risk early in your solution, and then you do the system architecture. And in that architecture, you have to document what design decisions you are taking. So meaning that if you are using an internal DNS versus external DNS, the DNS is something which you use to resolve the IP address. Okay, I like FUDN of the IP, and you get the IP information like from that DNS server. So this is just an example that. So why you're using internal versus external, where you are using firewall, what users you have in your system. So you have to make sure that whatever design decision you are taking in your system architecture, you are documenting that, because that would help you to identify that what has gone wrong and why, so you can troubleshoot some of the things. You have to define the governance model, that who is doing what, why he's doing it, what is the policy for that particular action. So this way you will be able to better control your communication across the stack. You have to identify the third parties. What are the third parties of your solution? If it's a user, if it's a commercial bank, if it's a payment gateway, if it's an Oracle, which I'm just using to take the data information, what are the third parties I'm using? Then do the third party security assessment of that particular interface of that particular stakeholder. Fourth is the key management custodian. So if you're using like retail CBDC or wholesale CBDC, in any of the solutions, you'll be using public key cryptography. So in that public key cryptography, you should have defined that what HSM hardware security module you will use. You will use an on-prem or a cloud one. Who would give me the certificates of my solution? How would I rotate my certificates? So whatever you're using, you have to make sure that the key management is being there properly. External oracles, we all use external oracles to get the data. So whatever data you are getting from the external systems, make sure they are validated and they are not tampered with, and so making sure that you have some sort of integrity checks in place for your data, the communication happening. Human factors, making sure that the internal, all the employees, all the workforce that you have for your design, they know that what practices they should do, and they should be constantly updating themselves from any cybersecurity threats like phishing emails. So any hacker can easily target the employees and they can have an access of the system, and that system will give you an access to the all other systems. So there's something which you need to consider. Last but not the least, it is operational and cyber resilience. So like things like patches, things like constantly updating your risk profiles, making sure that you have the backups, making sure that you are constantly doing the audits of your solution. Like bug bounty, hackathon, internal red teaming exercise. So you are constantly evaluating your solutions from threats, new threats, and then taking mitigation measures to actually prevent those attacks. So this is I know like a lot of information in a short time. I hope that you have enjoyed my presentation, and I'm sure that you will be having some questions. If you do have some questions, please do share it on the chat. Lastly, if you want to do some additional research and learning on this topic, this is my YouTube channel where you can go, and I have some like videos on zero trust security, on what CBDC, like what security solutions designs look like for CBDC. So this is, you will get more information on that. This is what I have just covered. Then the second thing is my book, which is available on Amazon. It has the paperback and a Kindle version. So if you're interested, you can buy and you can check out all the different topics. I have covered different topics what I've explained in more details with examples, with code, all the things which you can actually practically do some hands-on on this all stuff. So yeah, thank you very much. And back to you, Sola.
Thank you, Taha. A very indeed interesting presentation, a huge topic that it seems that we are all still need to be looking at it very seriously and considering the impact and the of the security risks that the world faced. So let me start with the questions now. I will take the question from Prof. Yaglis, unless George, you would like to just speak it out yourself. Or...
Yes, I can. I think I can. I wrote it down because I have an erratic connection here, but if you can hear me, it's better to say it. So Taha, first of all, thank you very much for the presentation. I found it very interesting. The question I have is the following. You presented a very broad nature of security risks, and all of them are very important for the success of a project, let alone of a very public project like a CBDC. I'm wondering, given the fact that from the user perspective, and when I say user, I mean the people or businesses that are going to be using the CBDC. So from their perspective, these security threats or considerations are very complex and very difficult for them to understand or handle if there's a case. What, in your opinion, would be the most important considerations that a central bank that issues a digital currency or a crypto token for that matter should take into account to make sure that the widest possible part of the population is able to use the CBDC without a problem? In your last slide, you had a number of recommendations like custody of keys and external oracles and stuff like that. But these are mostly considerations for the issuer themselves. What about the people? What would the central bank be able to do to convince someone like me, the average Joe, to use the CBDC? Thank you.
Taha, you're muted.
Oh, my bad. Sorry. Yeah, can you hear me?
Mm-hmm.
Okay. This is a very, very important and very good question. I'm glad that you have asked this thing, because cybersecurity is such a complex thing, and you end up having a lot of, you don't know what you need to do, you end up spending a lot of money. So there are two things here. One is, I will explain you from the central bank perspective now. Okay. So from the central bank, what I want is whoever is interacting with me, I should give them a secure means of interacting with me, which is like central bank. The interaction for a user, it can be a wallet application, or a graphical user interface like a web application where the users can access my platform, okay, to get the tokens, to get the currency from me, to upload the public key, whatever the interaction is been happening. Now, from the central bank perspective, I need to make sure that the endpoints, which is the mobile phone, which the end user will be using it, my software, or my web, or the Android, or the Apple application, whatever application that has been sent for the users to use, they should have some sort of an endpoint detection and response mechanism installed on their software, meaning that if there is a malicious event that has happened on their phones, which is like from any external actor which is trying to exploit the information or it's the private keys, we should have some sort of an alarm or a log generated from that activity. And on top of that, I should have some sort of a response also on top of that malicious file or malicious event that has happened. Meaning that if I have opened a Bluetooth now, for example, okay, and if somebody is trying to hack into my phone from the Bluetooth, so there should be an alarm that is coming to me as a central bank, and I should have an enforcement on top of that action, which is to shut down the Bluetooth, for example, for a user. Okay, this is as simple as this. Okay, now this EDR, endpoint detection and response, would help the central banks to convince the user that, hey, no matter what software you're using, if you're interacting with me, you are secure. This would help in building trust, like from the end users, okay, towards central bank. Now, this is first part of it. Now, from the user's point of view, whoever is using it, they should need to do their due diligence, meaning that they should be educated enough to know that, hey, if I keep the keys from 128-bit to 256-bit, it will help me to prevent any threats which are coming to 128-bit algorithm, for example. Okay, this is something which is like a due diligence on the user side as well, because here the central bank cannot do all the things. You have to also do something at your end as well. So something which is like a both-way thing, but it needs first education and then proper actually governance framework to implement such action. I hope that would answer like your question, Josh.
Yes, thank you very much.
Yeah.
Thank you, Taha. Thank you, George. We have another question from one of our students regarding privacy. He's saying that from a policy perspective, do you think it would be possible to integrate zero-knowledge proof in CBDCs in order to preserve sensitive payment for data information while also being compliant to KYC and the AML regulations?
Yeah, that's another very good question. Here, I would say when you talk about compliances and privacy checks, it depends on the jurisdiction where you are operating. So, for example, a country which is having GDPR compliances, or if you're in the US, you have a California Privacy Act in which you have to like do certain things on your data sets. So yes, like the short answer is yes, that you can enforce such a policy in which you can identify that what are the information you are taking from the user, or from third parties, how they are flowing across the systems, and what like prevention controls you are having on those systems in trying to avoid the exploits. Okay, in plus any data retention policies and anything which is there in that system. So you can technically architect that solution in a way that you can define the policies and some enforcements on top of it. But the second part is you have to constantly do an audit of your system to ensure that all the privacy checks are there, because you don't know that how the data is being flowing. If you scale up your solution, you will be having some more architecture options, and then instead of storing it like for example, in your initial solution, you're storing it in the SQL database, whereas in your future solution, you included some more data sets or data storage options for you. So the data now going to two different directions. So if you keep on updating and auditing your system, it will be helpful for you to understand what data compliance procedure I need to follow. So it's like an auditing plus the enforcement, but in both of the things, one thing which you need to take care is identifying what data sets you are collecting, where it is being stored, and what controls you are taking inside your stack to prevent any exploits. Yeah.
Thank you, Taha. Are there any other questions? Well, if there are no other questions, then I would like to thank you once more, Taha, for this wonderful presentation. And just to remind everybody that this is our last event for the year. And I would like to end it by wishing you all happy holidays and a very happy new year. And we're looking forward to seeing you in our upcoming events next year. So thank you all for being here with us. Bye.
Goodbye.